All right, all right. Hello, everyone. I am coming to you live from. Wait a second. You hear that? You hear that? Everyone, run! Ah, Okay. Oh, there, 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 there are more of them. More of them. Everyone, save yourselves. Okay. All right. Okay. Whew. Okay. Wow. I'm so glad we are all safe. I am so glad we're all safe. My name is Richard, and people like to tell me that I am an exceptional programmer, largely because my programs they generate a lot of exceptions. I love exceptions though, especially when they help me. For example, this is beautiful. Okay, name error. Did I mean to use chdir? Yes, I did. Okay, this error it brings me joy. But what about this code, huh? Syntax error. All right. Where's the syntax error? It says it wasn't expecting an end. Okay. But where's the problem? You might as well just throw up a giant sign that says dead end. The error points to the last line, but the problem is actually on the first. I'm missing a do here. If you're not familiar with Ruby's syntax, here are keywords that can trigger a required end. If you have an end statement that doesn't match a valid keyword, it triggers a syntax error. The trickiest one of these is do. In Ruby, do starts a block. This is valid Ruby code. Chdir with a block changes the working directory of the process. Chdir with a block also changes the working directory of the process, but switches back once the block is done. If we remove the do from the source code, it generates a syntax error. And so any method can take an optional block. You can pass a block to just about any method. Um, when you get a syntax error, Ruby will tell you that the problem is at the bottom of the file, no matter where you're missing a keyword. It's not helpful. It's very confusing. We're gonna fix this dead end problem. So first, I'd like to tell you about a scientific study I did on time lost to syntax error exceptions. I found the average developer loses about 100 hours of productivity due to these errors. When I asked developers what they wished for most in life, 78.3% of them told me that they wanted an AI algorithm to tell them where their syntax errors are. So let's do that. First, though, how does a computer convert text into a program? All right, well, you start off with some code, like here's just a really simple string, it's hello world. The programming language passes your source code to a lexer. Ruby ships with a parser and lexer, which is pretty sweet. It's called Ripper, which to me sounds like something from an album cover. Could be a band. It's pretty sweet. Ripper takes the source code and then converts it into tokens with significance. It will tell you the type of the character at the start of the string is a double quote, and the contents are "Hello World." And so we can use this lexing technology to tell us whenever our source code has a keyword in it. After the source code is passed through a lexer, it's then fed to the parser where those significant groups are turned into a syntax tree. All right. There we go. So this Ruby source code generates that syntax tree. At this stage, we can detect syntax errors. If we try to comment out a critical line, then our parser will generate an invalid syntax tree. An important trick that we're going to use later is that if you keep commenting out lines from invalid source code, you'll eventually be able to build a valid syntax tree, which also means that your code is valid. Okay, let's switch gears though for a second. Who here knows what AI is? Raise your hand in your homes. I can see. No, I can't see you. Comment something. Say me emoji. I don't know. I don't see anything. Nobody. Nobody. Real hat. Yes. Yes. This is live. Okay. Nobody knows what AI is. AI is artificial intelligence. It's a fancy word of saying. Oh, there we go. Algorithm.
I am more than an algorithm.
Oh, come on. No, you're not.
Fine.
Okay. So more specifically, AI is a goal-seeking algorithm. A common example of AI is pathfinding. You want to get from point A to point B. How would you tell a computer in order to do this? You need a way to break down the problem into discrete actions that either get you closer or further away from the goal. In pathfinding, that would be deciding what turns to take, what roads to drive on. And then AI also needs a goal. It needs to know when it can stop looking. For driving, the algorithm stops once the destination has been reached. Now, we can blend these two topics together. We start with bad source code. First of all, what's our goal? Our goal is to transform the source code until it can parse again. Once we've done that, we can stop searching. We know that the syntax error has to be within those lines. We can use our lexer to determine if our source code has a keyword. There's one other thing, one other piece we are missing, which is intent. So how does source code convey intent? What's a way? This code here is ambiguous. The end on the very last line could belong to either line above. One of these lines is missing a do, but we don't know. It's impossible to know. This code, on the other hand, is a little bit more clear that the developer intended line 2 to be a block due to the indentation. So uh, source code. Oh, sorry about that. That's where our do goes. So indentation is going to carry programmer intent. At this point, we've got all of the pieces that we need. Okay. This is real Ruby source code with a real syntax error in it. It's organic syntax error. We will use the dead end gem in order to find the problem using the tools that we've discussed. All right, the algorithm finds the largest indentation with 10 spaces on it. It finds the last of those lines and works its way up. Here we've hit a change in indentation. All the code is valid. We're going to check it with Ripper. We know the valid code cannot contain the syntax error, so we can comment it out safely. This block is going to be added to our frontier for future expansion and exploration. There's still more large indentations to explore before we can revisit the frontier. This line is valid. And that's it for code with 10 indentations. So now what? Rather than start exploring the 8 indentations, we can pop a code block out and expand it. These lines were generated when code already on our frontier were expanded up and down. When that happened, our lexer saw that we hit a keyword on line 51 with the if and an end on line 60, and so it pauses and checks it. It's valid. We can add the expanded block back to our frontier. We popped the same block, expanded the same block, it hit a change in indentation. Repeat again, we stop do an indentation change again. And at this point in time, the AI or algorithm has successfully found a valid lexical block that starts with def and correctly ends with an end. We could keep expanding that block, but we've got other unexplored code at higher indentation now. We go back to our add phase. Valid again. Keep looking. See the problem yet? Anybody? Hmm? Okay, back to our frontier. Expanding blocks up and out. Again. The code here looks dangerously suspicious. What happens when we remove it? Right, syntax is okay. Great. So our goal-seeking algorithm successfully found the invalid syntax nodes and removed them. It can stop searching. We then present these findings to the user. This is the actual output that you get from inputting that file into dead end. There are extra lines on 38 and 45 added in for a little bit of extra context and to accommodate an edge case I don't have time to fully go into here. Since release, Dead End has been downloaded over 144,000 times and counting by exception connoisseurs. And today we talked about lexing, parsing, syntax errors, syntax, AI, pathfinding, goal seeking. But really, though, I just want to take a second and just think about the non-technical pieces. It's the technical pieces aren't really what I want you to focus on. The important thing for me is that everyone sitting in this virtual room together is the future of developer tooling. Programming is inherently difficult, but it doesn't mean our tools can't help us. One of the best ways to judge a system is to see how it fails. When we give care and grace and beauty to our failure modes, then we can create experiences that delight us, experiences that teach us, experiences that elevate our code and our consciousness. A syntax error doesn't have to be an ending, it can be a beginning to a beautiful programming story. My name is Richard Schneeman. I go by Schneems on the internet. I created codetriage.com, easiest way to get started contributing to open source.
I want you to go forth and be an exceptional programmer. Bye bye.
Zoom wave, everybody, Zoom wave.